Okay, here we're going to talk about the basics of object-oriented programming. Now, this is going to be a little more advanced because I don't think you're going to be expected to do classes in object-oriented programming in your first session or your first class, but these are the concepts. It's more of a vocabulary thing and some examples and what you're leaning toward with object-oriented programming. It's everywhere, right? OOP is everywhere these days. So if you're going to software development, you're going to need to know this. If you're an engineer, you're going to need to know how to create objects because, well, I'll explain. So this won't take long, pretty short thing because we're just doing kind of some theory and I'll show you some examples when we're all done on a car. We'll make a car because a car is an object. So OOP is a programming paradigm based on the concepts of objects, right? And objects contain data. And these data, it's in the form of fields, code, and procedures, and everything that we just talked about earlier. Declaration of variables, those are going to be our instance variables. Our functions are going to turn into methods that make the object do things. And the good thing about OOP is it helps organize your code in a way that models real world entities. So when we write code, we're writing to build an object, right? You have objects interacting with objects, and that's what programming really starts moving into. So a class, this is what we're doing. We write a class to build an object. And a class is a blueprint for creating objects. When I say that, I mean I can write one class and I can have many objects of that one class. And when we refer to blueprint, let's say you're a home builder and you have a blueprint. Well, you can build as many homes as you want off that blueprint, right? You can build a whole neighborhood with one style of home. In that, it doesn't mean that you have to get a new blueprint every time you want to build the same house. You just build another house. You just look at all the stuff. And that's what we have. And any object has state, which are attributes, right? What is it? That's the attributes. And then it has behaviors. What does it do? So we've talked about Leo the dog. His state is he is a lab. He has 4 legs. He's 4 years old. So that's his state. Now, what does he do? Those are his behaviors or his methods. So his state is name, Leo, and what he does is runs, sleeps. So those are the methods. Those are the things that make Leo an object, not just the state, but what it can do. So an object is when we make an instance of the class, which is called instantiation. It represents a specific time that object is created, okay? And it gives its own unique behaviors. So just like any object, when you create the object, then the object is usable. And that's what we do in code. So let's look at a car. Our state or our attributes is a color, brand, and model. That's the state, right? That's what makes up the car. Our methods or our behaviors are it starts, accelerates, and brakes. Okay, it does much more than that, but we're going pretty simple here. So if we wrote a car class, which we'll do after this is over, we're going to give it color, brand, and model, and then we're going to go ahead and accelerate our car to a certain speed and then stop. So it does something. That's an object. There are 4 pillars of object-oriented programming. Now we're going to actually use the first 2, but not the next 2. That we'll save those for when you become better programmers and when you start your Java class or when you get to the next object-oriented programming class, you'll get into inheritance polymorphism. But we'll see abstraction and encapsulation on our first class that we make. So abstraction hides unnecessary information and displays only necessary information for the user during interaction. It essentially represents real-world objects in a simplified manner for users to interact easy with. So we want to hide specific information using abstraction. The user doesn't need to know how. It just needs to know that it does. And that's the abstraction. So if the user's like, oh, because we'll write a little program that uses a random number. The user does not have to know how we get the random number, just that the number shows up. And that's our abstraction. Encapsulation is when we bundle the data and methods that operate the data within a single unit called a class. So we're going to encapsulate all these things. It helps hiding the internal state of an object and only exposes the necessary functionalities to the outside world. So you can see these two work kind of in tandem. So encapsulation allows us with like methods where we can encapsulate that piece of code that does a specific task into a method, and that helps with modularity of the program. And it's kind of fun. Inheritance is when we have inherits properties and behaviors from an existing class, right? So we have different types of inheritance, composition, and anyway, we'll get into that later. But let's look at this. A car is a vehicle, right? So I could write a vehicle class. And in the vehicle class, I could have all the attributes of vehicles. Then I could write a car class, and I can inherit from the vehicle. Then I can write a motorcycle class, and I can inherit from the vehicle, and I can write a truck class, and I can inherit from the vehicle. All those inherit because they have some sort of relationship to the superclass or the above class. So again, we use animal, right? We can have mammals, and then we can have dog, cat, bird, whatever mammals you want to have, and then you can have non-mammals and fishes and stuff like that. So some fish are mammals. Anyways, I'm not a biologist, but we inherit from things that like items, right? So if you're a game developer and you write a bad guy, a zombie, right? You can inherit different traits of that zombie and throw them into different types of characters, right? Write one fighter class and have 1 million fighters. That's not inheritance, by the way. We'll get to that. Polymorphism, fun to say, easy to do. It really is simple because poly just means many, morph means shapes. So all we're doing is allows for objects of different classes to be treated as objects of a common superclass. This enables flexibility in programming by allowing methods to be overridden in subclasses. Let me explain what that means. So we have a human, or let's say we have a student class. And your student class, we make one student, student A. And then we're like, it acts too much like a student because student A is going to, then we're like, we want to change the methods of the student. So in a situation, the student is going to act differently. Let's say we have a method. The student's method is headphones, right? So when the student's in class, the headphones aren't in, ideally. I always have one in sometimes. And then when the student's not in class, the headphones are out. Or when they're in class, they're out, and when they're out of class, they're in. It's the same method, but the behavior becomes different. So we can actually morph or change the behaviors based upon the situation that is needed. And then we get into vtables and all sorts of runtime binding and compile time. Compile time and runtime binding and things like that. So polymorphism is pretty cool because you get to change behaviors of a method so that one instance of your object doesn't exactly, they're not all actually the same. There's changes in behaviors. And that's what that is. It's not overly complicated. After you get inheritance down, you've already done some sort of polymorphism when you start overriding methods, right? When you change the signature in your methods, that's a form of polymorphism. So once you get inheritance down, and then you run about your access things where it's public, private, or protected. Again, when you get into OOP, after you learn how to program a little bit, okay, then jump right in and get going on it. It's pretty fun. All right, best thing, we use OOP a lot because it gives us modularity. We can organize our code, we can troubleshoot things, we can have patches built, we can fix single methods, we can add behaviors to state. We don't have to redo the whole thing. New features are added without modifying a lot of code. Let's say we have a banking app and we need another method for one of our applications. We can just add a method to it, a new behavior for our application. Game programming, objects interacting with objects. And then it's easier to maintain. If you become a software dev person, you'll probably be doing code maintenance right? That'll be your first kind of job, your internship. They'll be like, hey, this isn't behaving correctly. Can you fix this up for us? So you can debug because you're working on specific areas of the code. The code can still work, but you can make improvements because you can tweak specific pieces of it. And that's the cool thing about it. All right, we're going to head over to the compiler. Let's make a quick car class. We'll talk about some of these things. We'll look at some examples. And then the next video, we're going to build our get rich quick. We'll build an application that's going to make us millions of dollars. Okay, so be right over there on that next slide. And here we are. Okay, let's just start in the main. We'll talk about this in a little bit. Okay, so we're going to build a class. We're going to build a car. We're going to build a car class, and it's going to make a car object. So we're going to build a car that's going to be a red Chevy minivan. And then we're going to have methods inside. Remember, this is going to be our state, and these are going to be our behaviors. And how do we build a class in C++? Again, this is going to fall to your instructor and how they like to teach C++ and what direction they go. All right? But I've separated my stuff because of, we talked about encapsulation and data hiding and stuff like that. So this is my car.h file. And for me to get new files, I'm just going to, because I'm adding a class. So I have this here, and I'm just going to add a class. So what did I do? I right-clicked on my Solution Explorer. I went to New or Add, and then I went Add Class. And what that does, it brings this up, and I give it a name, and it gives me an H file and a CPP file. These, we'll talk about how C++ compiles code in another tutorial. So this is my class. Keyword class has to end with this. Man, when you guys start programming in Visual Studio, do not erase Pragma once. Okay? Just don't do that. Don't do that. Let it be. I included IOStream and I included string because I'm bringing strings in. So here's my class, name of my class. Good. Bracket, everything inside of here is my class. Okay, these are my instance variables. And we call them instance variables because they're the variables that instantiate or build the state of my car. Again, my car is going to be, it's going to have a color, it's going to have a brand, and it's going to have a model. My car is going to have speed, but the speed is only set to 0 because when it starts at 0, that's where your car starts. And then, so these are private. Okay, these are access modifiers. This is public. This says, okay, everything is accessible. So now I have this little silly thing, looks like a method. It's called a constructor. So this is my default constructor. Now I have a constructor that fits with color, brand, and model. So I'm going to pass in what type of car I want. This little tilde on here is called the destructor. So whenever we build something, we want to go ahead, when we're not using it anymore, we want to destruct it. So we want to take it out of memory and free up that memory when we're not using it. So when we're done with using our car, the destructor will come by and take the car out of memory. Now I have a simple method. It says void show car. This is an inline method because we're going to go over to our CPP and fill these out. So we can give this header file to anybody and be like, hey, this is the car. And then they would be like, okay, I'm going to write my own show car and drive car. So we don't have to show anybody, any other developer, or, we can give people our .h files because we're not giving our algorithms away. We're just giving what our method names are. And that's kind of cool. Go over to car CPP and notice I have to include car.h, but here's what's funny. I don't know if it's funny, but here's what's different. Notice that there's quotes around car.h because that's different than an include library. So if we're including our files, our h files, we put quotes around it, not carets. Now I have my namespace standard and I have my default instructor, but what do I have to do? I have to go look refer to my car.h file. Parameterize video. It should be anyways. And then I have my speed set to 0 since the constructor is public, that makes speed public also. Now I have my method show car that was in my H file. I'm just filling it out. And it says I have a whatever color, whatever brand, whatever model I pass in. Then I have my destructor, so I can get rid of my car when I'm done. Then I have a method drive car, and it says I at 0. My car can go up to 100. It's one time every time. And then it prints out my car. Okay? And then it prints out it's driving at whatever speed I start. I have a condition here that says if speed is the same as 75, that's fast enough. And just speed through this, comfortable with some of the terminology, because when you get into your next class, objects are really, really important, I promise. So now, what am I building? My object is car. What's the name of my car? My name is my car. What type of car do I have? Remember, I get to pass in my parameters. So I'm going to pick a red Chevy minivan. And then I show car and drive car. So when I run this dot allows me to access my car does what? It drives. So that's access. My car's behaviors are accessed. So here's my car. It's driving. It gets to 75. It says that's fast enough. Pretty simple. But here's what else we can do, right? We can do my car, my new car. So what am I doing? I'm building a blue, we'll just keep it blue Chevy Tahoe. Now, what did I do? I have two cars, right? I have two cars. I have a car called new car, my old car called car. And why are you not the right color? Oh well, we'll run it. Visual Studio is silly sometimes. It says, oh, you have an error, but it doesn't. So now I have two cars from one class, many objects. I could have a whole fleet of cars, and they all go 70 miles an hour. But I could change it so that my new car could do 85 miles an hour, because I can modify that stuff. So that's a brief introduction into classes. Just get familiar with some of the terminology, but spend more time practicing building functions, loops, conditionals, arrays, and vectors, and do that sort of stuff. And then we'll go ahead. Our next video, we will build our get rich quick scheme. All right. Bye-bye.